Hi there, welcome to Mini Math Lessons with Karen. Today I am further exploring some linear programming problems. So there's two activities that I'm going to kind of give an overview to, and the links to those activities are in the description below. I'm using Classpad.net, which is a dynamic math software. You can do, calculations, geometry, statistics. Here's the landing page. You don't have to have an account. You can just start exploring, and the activities I share, you can use them without an account. But I suggest creating an account. They're free, and you can then save the activities that I've shared and change them, modify them, however you want. So let's get right into it. So I'm going to do a couple things here. In the first activity, I'm just going to show you some way how you can graph and limit the domain. And then in the other one, I'm going to show you the next step, like once you have the feasible region of a linear programming problem, how do you help answer questions and make decisions? So in the first activity, it's talking about manufacturing of two products, A and B. There's constraints that are given in the problem. So A takes 3 hours, B takes 6 hours. There's two different things going on. They have to finish and produce. So 3 hours to produce, and then 6 hours to finish. B is 5 hours to produce, 2 hours to finish. And how many can be created in a 24-hour period of time. So that's sort of where we're going. So the first thing students are asked is, from this information, can you create some equations or inequalities to represent the constraints that are in the problem? So that's the first step. We've asked them to define their variables as x and y. So A might be x, B might be y. And then once they have those, they come down and they actually graph them. So it's pretty easy to graph inequalities. So I'm just going to show you briefly some of the things. So one of the things is we know that you can't have less than 0. You can have negative production of these products. So X, which we're going to call product A, has to be greater than or equal to 0, right? Because we can't have less. So notice what happens as soon as you do that. You have this shaded region that comes up. So then we also would have to have the same constraint for B, which in this case we're calling Y. And I am going to show you how to get if I need the greater than or equal to symbol, I am using this math template that comes up, or your keyboard, which is what I did the last time. But it's in this template here under math, first tab. And so this also has to be greater than 0. And so now I'll have a second shaded region. So one of the questions here is, what do these shaded regions mean? So what's this pink area mean? What's this purple area mean? So students are kind of seeing the color overlaps and realize that it has to be the overlap, the purple, that's going to help answer this question so far. But we still have some more constraints. So one of the things is we have production, and then we have finishing. So A is 3 hours to produce, so 3x, and B is 5 hours to produce, so 5y. And that has to be done in under 24 hours, right? So that's sort of what that means. So we're going to have to say that that's less than or equal to 24. So that's for production. And so notice we have this now third one coming here. And so now this overlapping area is getting a little bit less. I don't know what color we'd call that, but here's our feasible region so far. We still have one more constraint. So that's 2x. I'm just checking up here. No, I say that wrong. 6x and 2y, also less than 24. So let me change that number. 6x and 2y to finish, and that has to also be less than or equal to 24. All right, so now I have all my constraints, and they are going to then basically explain what that means. And I'm just going to talk through the rest of the problem. So as you can see, I really am only interested in this part. So then in the next step, it asks them to just look at the feasible region, which they can then do by changing this to an intersection versus a union. And they're only going to see then this feasible region. And then they're given some more constraints. So what I'd like to do now is just look at the other activity and go through these last steps, because the activities are very similar, obviously, but just different situations. So in this activity, it's basically a bicycle company, and they are producing two different kinds of bikes, and they don't want to make more than 900, and they don't want to produce, they have to do at least 600, so basically 600 to 900 in a year. And so that's their goal. So just to save time, I've already entered the constraints of this problem, because what I really want to focus on is this last section. So they're going to need to know, here's the feasible region. I've done intersections, and I want to show you what happens when I click on them. I get the key points, and so I want to basically create a table of values that has the 4 vertices. And so, I don't know why it's not letting me do it. So I'm going to just pull out a table here to record my things so that I don't forget them. So I have 675 and 225, and then let's go to another one of the intersections here. And so then I have 450 and 150. And then let's get the next one. So all I'm doing is clicking on them. So we've got 600 and 0, which is interesting. And then we also have 900 and 0. And so what do these values mean? Students are going to ask, so if X represented the first type of bike and B represented the second type of bike, these are the feasible production amounts for each, right? So I'm going to scroll this down here so I can actually use it to kind of explain what we're doing here for the last section. So it's saying, okay, you've determined that they should be able to make a profit of $60 on each road bike and $75 on each time trial. Which one's going to give them the most money, basically, is what we're doing. So what we're going to do here is simply take these values and do 60 times 675 plus, what's the other one? 75 times 225. And there would be my estimated profit, 57,000. So they're going to basically take each of these points of the vertices of the feasible region and calculate them out and see which one is the optimal value. So right now you might say, oh, well, you wouldn't do this because you're not going to make any money. But let's see what we make if we just make 900 of the first bike. And it's not quite as much as this. So right now this might be the most, but we want to make sure we test this one out as well. Well, actually, we don't even need to test it out because you can sort of already tell. But this is what students are doing, is determining based on these possible solutions. There's many possible solutions in here, but these are the optimal ones, right? And is which one is the one to use the most, and it turns out it's going to be this one right here. So different ways to look at this problem, different how to graph it, and then how to do that. So that's what this was all about.